Good afternoon. Thanks for coming in. Today we'll talk about artificial intelligence. AI is a buzzword and it's kind of cool to talk about it, right? But what is not talked often about is the value that AI delivers. AI is quickly getting commoditized. Wherever you see, you're seeing applications of AI everywhere. So how do organizations differentiate when everyone is applying AI? So what is the strategic differentiation? Where is it coming from? So that's what we will talk about. Two things. One, how do you get value out of AI? And number two, how your organizations can achieve strategic differentiation and how they can adopt AI. That's the focus of today's talk. But first things first, let's get some definitions straight. We'll look at what artificial intelligence is. But no, I'm not going to give you a Wikipedia definition. Check this out. So if it's written in Python, maybe it's machine learning. If it's written in PowerPoint, it's definitely AI. So have no doubts. Today we'll definitely talk about AI. Quick introduction about me. I'm Ganesh Kesari. I'm a head of analytics and co-founder of Gramna. At Gramna, we convert insights into stories. We help solve business problems by applying analytics on data to identify the right deep insights. And we use visualization to convert these insights into engaging data stories. And we work with 100 plus clients around the world, and we help them adopt data science. We help them apply and execute AI and build solutions which they can fit into their day-to-day business operations. And importantly, we help them scale AI organization-wide so that there is propagation and there is differentiation. And personally, I'm passionate about simplifying data science for everyone. I write and speak about it, and my passion is about explaining complex concepts in simple English, and I try and talk about the real-world applications in a simple manner. So with that, let's get started. We are in an age of AI, but if you look at the success rates of projects, over 80% of projects fail. And this statistic from Gartner is shocking because this is projected to continue for the next couple of years as well. So the failure rate in AI projects is very high, in spite of the millions of dollars which organizations pour into AI initiatives and the kind of careers which are at stake. A lot of people are joining this bandwagon, but if it often leads to failed projects, what does it mean for them? So to understand why AI projects fail, let's retrace a typical AI journey. So we have a large financial enterprise which has decided to embark on AI journey. So they snap up some AI researchers and PhD data scientists, and they bring them on board, and they make a splash in the news saying they are getting AI driven. And then all the while the business teams and the analysts wonder what's all this buzz about and how is it going to be very different. And finally, when the rubber hits the road, these people start reaching out, and they have the broad mandate that they can go and pick any data they want, and they can unfurl their magic with data within the organization. So when they finally reach out, the reality is that they have to talk to 10 different teams to even get a portion of data. And after a lot of approvals, finally they manage to get a very, very small slice of what they originally were planning to. And then what happens is they start applying their deep learning algorithms and cool AI models on this data. And they come up with pretty exciting results which they find interesting. When they present it to the business teams, they get met with a very lukewarm response. So they say, yeah, this is all cool, but maybe we are not sure how to use it. They say, okay, maybe you talk to our analysts and they will figure out how to use it. So that is the end of AI pilot. And similarly, these people move on to pilot after pilot. A lot of such cool, interesting things get built but never get used. And after a few months, the AI researchers or the data scientists get bored that they are not having their creations come to life and they leave. Or the executives finally realize that there's not enough ROI and they shelve the initiative. So this hypothetical scenario, we've seen it play time and again in every organization, whether it is small or large. So what causes this failure? There are three prime reasons which leads to these false starts. Number one is going after what is interesting as opposed to what is impactful for the business. Second is picking whatever is urgent. When you ask someone, they talk about 100 problems which are top of the mind, which are urgent, but all of them may not be aligned with the strategic business priorities. And finally, looking at what is possible as opposed to what is really feasible. There's a very subtle difference between these two. Possible is something which is beyond feasible. There are other things which may not be really practical in the real world scenario. For example, if you start with a pilot, if you take a small set of data, you can do a lot of things. But when you have to productionize it, when you take it to the real world and you have to implement it, roll it out to thousands of users, it doesn't scale. So there's a major issue in terms of productionization of AI initiatives, and the feasibility is one of those challenges. So look at what is impactful, strategic, and feasible. So that is the right starting point. And we often say that if you are starting a data analytics initiative, you should not talk about the data or the analytics first. You should start with the business priorities. So we look at how you can do that. But the summary here is that most insights don't deliver business benefits because they solve the wrong problems. I equate it to doing a 30-hour marathon hike. So you might have the best of gear and you might have optimized the route. But if you pick a wrong target, you might end up in the wrong place and all of this effort goes waste. The AI journey is like that. You need to make sure that you're going to the right destination and all of the other optimizations can happen later. How do we do that? There are 3 stages we will talk about right from the beginning, where you identify the AI projects, build a data science roadmap, and then how you scale it from pilot to project stage. And finally, how do you measure it so that AI can propagate within the organization. We will look at the 3 stages, what are the focus areas needed in each, what skills, roles are required, and also I'll talk about one critical aspect on how people can make a career switch. A lot of questions in terms of people who are in non-data science roles, how can they make a switch to it? So when I talk about the skills, we'll also look at what are the essentials for critical roles in data science. Phase 1 is what I call experimentation. So we have initial, the start is by talking to the executives and onboarding the executive support. We need to always start from the top. Make sure you have the mind share of the executives and align with the strategic business priorities. Look at where the organization is heading the next quarter, the next year, and align with that. And build a data science roadmap. We'll get into the details of how we do that. Firstly, when you onboard executives, you should ask not just for the budget, but for their time. In the early stages, the more time executives spend on an initiative, the higher the probability of success. So it's important to make sure that you huddle in a 2 or 4 hour workshop to talk about which problems are important for the organization. Who are the user groups you should first target? What business problems of these user groups are important? So that is the business-driven approach you need to take. Start with stakeholder groups, identify the objectives that they are trying to meet, and then identify the initiatives which can help meet those objectives. And then you need to find out the questions which you have to answer to make those initiatives successful. And finally, get down to the data to find out which data points are available which will help you answer those questions. And to get this to a completion, you need to do the path backwards as well. Start with the data, find out what kind of questions that the data can answer. Independently, you can find out this reverse track as well, and find out which initiatives the questions will help address. And finally, do they meet any objectives? If yes, what objectives do they meet? Because a lot of data-driven initiatives will be interesting for the technical people, but when you look at tying it back to the business audience, it may not add up. So this validation is important. And finally, look at which user groups will be enabled. So once you go through this process, you'll come up with a laundry list of initiatives. How do you prioritize and build a roadmap from there? There are 3 levers. We already talked about impact. Impact is the first one. Find out what is the revenue or the breadth of usage, or impact in terms of reducing some manual efforts. So identify a metric which you can measure, and preferably try to measure this in terms of dollars. The second aspect is, for every initiative, identify the feasibility. Look at whether the data, technology, or in terms of other availability of budget, people. So what is the feasibility to execute an initiative? And the third lever is urgency. There are certain initiatives which are needed as of yesterday, and if you have a conversation with people, they will say everything's needed as of yesterday. But you need to do this prioritization and ask which of these initiatives, if you have to pick a number and only some of those can be as of yesterday, which are those initiatives? And then there are others which the business teams, those missing needs are starting to hurt, but you might have a few weeks' time until you can address it. And finally, the third one are those where you have an expressed need, but it's not hurting them yet, and they can live with it for maybe many months. So if you can slot every initiative into these three categories, now we can get into the matrix where we have these quadrants. The ones which are high on impact and high on feasibility are those quick wins. Those projects you have to pick immediately and get started right away. Those which are strategic, which are high on impact and moderate on feasibility, you can't start right away. You need to find out whether you need to get some more data, some more technology, or you need to hire people. Find out what is needed and make sure you solve those problems. And any of those initiatives which fall into the low impact or low feasibility category, you need to further do due diligence to find out what are the hurdles, can it be solved, how important are they. So when you place all of these initiatives color-coded with the urgency, makes it easier to spot out. The green bubbles which fall into the quick wins, strategic quadrants are the ones you will have to queue up earlier in your roadmap. And the other ones can come in, say, 3 months, 6 months later, and all others can either be deferred or planned for the next year. So this way you have to build your data science roadmap and you convert those broad business asks into concrete projects. So this is the very first important stage. One aspect I wanted to highlight here, we talked about feasibility. Data always comes before AI. This might sound obvious, but in reality, people often miss that. There are several conversations we have with our prospects, and I'll quote one example. There was a very large financial institution, I'll not name them. So they approached us and said, we want to forecast our financial parameters. So we said, yeah, great, let's do that. And they said they wanted for the next 3 months. And when we asked what data they have, they said, we have last month's data. We said, okay, what else do you have? They said, no, that's it. We have last month's data. Can you predict for the next 3 months? So we took a lot of time to explain and try to understand where the data is stored, because these are financial metrics. You might have them somewhere. And they said, yes, all of these are there in different Excel sheets. We haven't set them up in a warehouse. Someone told us that there are algorithms which can predict numbers very well. So we want to do that first before we set up a data warehouse, which will take next 6 months to do. So this is the challenge which every organization goes through. You need to understand what comes first. And there's a hierarchy of needs in data science. So this is the hierarchy. You start with collection of data. It could be user-generated data or IoT data or the regular transaction stuff data which you ingest into your data warehouse. Second stage is where you set up all of those, the ETL mechanisms to get the data and store them into your data sources, like big data, warehouse, all of those sources. Stage 3 is where you do some cleaning. Even when you have data in your warehouse, it is not ready for analysis. You need to clean and make it ready to be used. So that is a very painful manual effort. So you need to go through that in terms of anomaly detection, preparation, and cleaning. And the next stage is when you can start doing those reporting out of it. So the basic BI reporting, MIS reports actually come in this stage, stage 4. Machine learning algorithms come into the next stage, where once you have the basic analysis pivots done, you can start exploring, go beyond the exploratory data analysis and start applying some simple machine learning algorithms. And finally, AI, deep learning, all of these are at the top of the order, where you need to have all of these 3 steps done, because even before you apply AI, you need to do exploratory analysis. You need to set up some experimentation frameworks on how you're going to evaluate the algorithms. So all of these steps are needed to scale the AI pyramid. Next question is, what skills do you need? So do you need the PhDs, or do you need multiple different skills in terms of visualization, algorithm creation, engineering? So the moment I say data scientist, so when you talk about AI skills, data scientist comes to mind. So when you say data scientist, what do you visualize? You imagine colored Venn diagrams with overlapping skill sets. So you have people with, you at least imagine people with data engineering, machine learning, visualization, business domain, communication skills, ability to walk on water. So you might have better luck finding an Avenger to save the world than find a data scientist who fits this job description. But in reality, when you go through all of the job descriptions, they call out 10 or 15 skills, which even set of 5 or 6 people within a team may not possess amongst them. So when you get started with your data science initiative, do not look for specialists. Get started with generalists. And we've had greatest success with picking people like people who have the business analysis skills, who can be retrained quickly, who have more breadth. They could have broad skills in different areas. In addition to domain understanding, they would be able to analyze data with an Excel sheet. They have an eye for presentation, eye for design, and have communication skills. So when you have these 3-4 broad skills, that is most important to get your initiative launched. So important other softer skills are curiosity and an ability to learn on the go. So if you have people like these, they are your most prized assets in stage 1. So go with the generalists and get your initiative started. So once you have these people, what tools do you need? So that's the next challenge. And these are the set of data engineering, data science tools in the market. And this is not an exhaustive listing. You have a much longer list if you Google and find out. A lot of organizations spend months in trying to optimize and find the best tool. They do an evaluation of 5 different tools. They have a lot of demos running. And that they spend almost 3 months choosing the tool. And all the while, the business problem is not solved. The first stage, the tool really doesn't matter. Pick the people, let them pick the tool. Because you're starting with generalism with certain set of people who are going to execute your initiative. Find out which tools they are comfortable with. Most often, they might already be familiar with some open source tools. So let the people pick the tools and get them started with that. You will have plenty of time to standardize and optimize the tools in subsequent stages. It's not needed in the first phase. So to summarize, phase 1, start with the executive mandate, align with the strategic priorities, build the data science roadmap, prioritize, and then come up with something which is 6 months or 1 year visibility. Get the data right before you launch analytics. Start with the generalists and let them pick the tools. To summarize, in the first stage, you would organize this as a central hub. So you have to have this organized centrally, driven by someone with a strategic mandate for this to survive and succeed in the very early stages. I often equate this to running a startup. You have very few resources in the initial stage. You have to make use of them and be more resourceful with less, and see how you can succeed by catering to a small audience. Build and deliver some quick wins, quick ROI. That's what will help you see the next stage. A quick case study before we move on to the second phase. This is from Google. Early stages of the Google Brain team. Andrew Ng was the person who was leading the Google Brain team then. He's also the co-founder of Coursera. So he had a tough time in selling deep learning internally. So most of the internal teams didn't want to use deep learning. This was many years back. So it was not only not very popular, it was uncool. Many people did not believe in neural networks. So he had a tough time convincing teams like the search or the ads teams, which were the most powerful back then. So instead, he got some leeway where he was able to get started with the voice recognition team, which was not very influential back then. So taking that, he implemented deep learning algorithms, delivered very good accuracy, so that those initial pilots were successful. And then the second project they got was with Google Maps, but that was not for any of the strategic features. It was to improve the data quality. He took that up and then implemented algorithms. So slowly, project after project, small pilots, he built momentum. And eventually, this reached multiple product teams within Google. And today, we all know the fact that it's not only at Google, deep learning is powering most of the products across organizations. So this is the kind of effort which is needed, just like working like a startup and making sure we are registering quick wins. That's essential for stage 1. Phase 2 is when we are scaling beyond pilots. We need to move from pilots to projects. There's a risk if you don't do this soon enough. Pilots might give you some quick wins, but if you keep doing that for a long period of time, eventually the momentum is lost. So there are a lot of small wins here and there, but then the teams move on. So you need to transcend from pilots to projects and try to align closely with the business teams so that you can move on to, say, sign up for a yearly agreement or a multi-year agreement. Align yourself with some of the product roadmap. So you need to get that alignment quicker so that you can move on to the stage 2. So extend relationship with the sponsors, business units, find more data sources to use, because we talked about quick wins where data is readily available. In the second stage, you need to get into some other data sources which are beyond the obvious ones. At this stage, what challenges do companies face? There's an O'Reilly survey where they had looked at the typical challenges faced by organizations in various sizes and at various stages. So the companies which have moved on from evaluation to the next stage, which is moving on towards maturity, there were 2 major challenges which were called out. Let me read it out. The first challenge is lack of data or data quality issues. This continues to be a challenge in the second stage as well. And by the way, even in a mature stage, data quality issues continue because the kind of data that, say, a deep learning or an AI algorithm needs, clean, labeled, qualified data, it's tough to come by. So that challenge continues. But the second challenge is interesting, where they talk about lack of skilled people and difficulty hiring for the required roles. So we hear this all the time. And when we move on from phase 1, where I talked about generalists, this is the time you need to bring in specialists. You need to start hiring for skill-based teams. What are the skills that you need at this stage? There are 5 primary skills. The first one is what we call the data bootstrap skills: strong passion for data, ability to handle and identify insights through exploratory analysis, domain awareness, and very, very basic understanding of design. Second is the deep domain expertise, strong functional understanding. The third one is programming expertise, statistics and machine learning, and information design. And by no means, we are not getting into a Venn diagram again. So these are 5 different skills which people in a team will have. Now we'll talk about the roles where not more than 2 of these skills is needed for any combination. So what are those combination of roles? The first role, and one of the most important ones, is that of a functional consultant, which is now being called as a data translator. Until a year back, people were not talking about it as much. But this is a very important role, and that's closest to this audience. People from a business analysis background fit in here once they pick up the data bootstrap skills. So these are people who understand the business and are able to pick the right projects. And they're able to translate the business needs into something to do with the data. And they act as a glue within the team to translate this into what programmers can understand, what statistics experts can understand, what designers can understand. So they act as a glue within the system, translating the business back onto the data science language. And once the solution is built, they translate the solution back to the business users, and they help them with the adoption. So without this role, you can clearly see 2 islands floating. One is the business teams, and the other is the cool solutions which people have built. So they help bridge both of this. And a lot of people reach out, when they reach out to me for career advice, there are folks who have 10 plus years experience in an industry. They have deep domain expertise. So this is one role which I suggest for them to take up. Otherwise, the common misconception there again, when they ask, they say that, should I do a data science certification, data scientist certification? They go about learning programming, they learn Python, they learn, say, the deep learning algorithms, they learn design, like visualization. It's not necessary to pick up deep skills in all of these after having 10 years of experience in an industry. So this role fits in well, and people from the data consultant or functional consultant role graduate into that of a data science manager, which also is closely related to this. We'll see that more about that in the third stage. This is one primary role. The second one is that of a machine learning engineer. This is different from a software engineer in that these are the people who bring the models to life in a working application. So you have to package the models and make this available so that people can consume it. So these folks do that. The third role is that of information designer. These are designers who have an understanding of data. They understand how you can translate data and explain it in a language and present it visually so that everyone can understand it. And finally, we have the data analysts. These are people who come from a statistics and machine learning background. So in any team, you have a combination of all of these roles, and these roles are almost mandatory and essential today. A few years back, not many teams had it, and the organizations are running with few generalists and a combination of this. But now, more and more, these are getting standardized. The terminology for these roles varies widely even today. The industry is still stabilizing, so you would see the same roles. Say, for example, data analyst, people also call it as data scientist or statistics expert. There are various terminologies used. That will probably take a few more years until people settle on what is really cool and what they can call these folks. But what's good to understand and assume is that these are needed. And another emerging trend when you talk about roles is that apart from these essential ones, now people are also talking about new roles like behavioral psychologists. So machine learning, ultimately the intent is to try and understand human behavior, whether it is understanding churn of customers, attrition of employees, or behavioral segmentation. All of these we're trying to understand how people behave and how they interact with the product. So for those people, to understand these people, it is essential to get those psychologists into the room. And this is another soft skill which is quickly getting added onto the data science teams. One caution here is when you get into skill-based teams and form the centers of excellence in stage 2, you have to watch out for over-specialization or silos, because then people might get into their own worlds and you may not have enough collaboration amongst each other. So to summarize stage 2, we moving from pilots to projects, extend the relationship, getting deeper with the sponsors, bring in the specialists, form the centers of excellence, and evolve the execution model. So at this stage, it is important to look at how you can start taking some risks, how you expand beyond the obvious, whether it is in terms of data sources or in terms of the problems. A quick case study is that of, we worked with a large technology manufacturer and helped them set up the customer experience analytics team. So this was a central team set up under the CEO, and the mandate was to understand how customers interact with the technology products they were selling and what was the feedback and how to improve satisfaction levels. They started off, like we saw in phase 1, they started with picking a small pilot, voice of customer analytics. There was a survey which was being sent out, trying to understand what customers respond in the survey. That was stage 1. And then there was some quick wins registered in that stage, which eventually led to a phase 2, where beyond the initial set of teams, they started moving on and they mapped with the product teams, marketing, and sales teams. And also newer channels of data, apart from the standard survey, look at social media data and all other sources. So can you collect more signals about the customers? Can you interact with more teams internally? And expanding the footprint into a multi-year mandate. So with that, the results and the benefits were much larger for the organization, securing an even longer footprint. Phase 3 is when we get into the integration stage, where it is essential that AI has to scale and it has to become business as usual, where every person is comfortable using the data and is comfortable using it for decision making. It has to be diffused organization-wide. So from a center of excellence, hub to center of excellence, to what is the model in which it can be diffused org-wide. So this is the structure. So we will follow a hub and spoke model. How does it work? Hub is a central group headed by a CXO, someone with a strategic mandate. And this is something which is a continuation of what we had in the earlier stages. We have the central team. So we want to have this team own up the hiring, own up the performance, and making sure that these initiatives are adequately staffed. While the spoke are the business market-facing teams. These are the business units which should now start owning and managing the product. So far, you would have seen that this has been centrally run. But at this stage, the ownership and the project manager for AI initiatives come in from the business units. And for this hub and spoke model to work, what we need is a crucial gray area. So why is it a gray area? This varies organization to organization. We can't force fit it saying that all of these roles have to be only in the hub or only in the spoke. As organizations mature, what you would see is that they initially start with a central core which is big. The spokes don't have much of a capability initially. And then over time, the hub starts shrinking and the capabilities get transferred to the spokes as you engage with multiple teams and they get the know-how, they understand how projects are executed. They start hiring some of those skills within the spokes. And at a steady state where things are much more stable, you would have the hub to a basic minimum where you have the executive mandate and you have few people being hired and passed back to the spokes. So this gray area is where you have overlapping responsibilities and organization to organization, you need to flex, scale up, scale down based on that. And finally, execution teams. We talked about multiple AI initiatives. So for each of these initiatives, you have to staff them with execution teams. They would come from the hub, the spoke, and the gray area. And all of these would be the roles we spoke about. We spoke about the functional consultants, data engineers, and so on. So all of these roles will be part of the dynamic teams. Once the initiative is executed, they would go back to their respective teams. And then they come back and form a new team to create and execute a new initiative. So this was published recently in HPR. And over the last 10 years, we've been building data science teams and we've been advising organizations to do that. We've seen that this is the most efficient way and a scalable way of expanding AI and data science capability across organizations. So apart from the organization structure, a few other important points for stage 3. We've heard about big data. In a way, it is notorious. People interpret it in various ways. There's also another terminology called the dark data. What does it mean? It's the inaccessible data, data which is not is conveniently forgotten. Examples could be you might have archived some data onto tapes, and that is not used anymore. But there's a lot of value. You have audio conversations on tapes or video logs on tapes. With deep learning, you can get a lot of insights from audio and video data. So get that data back. Forgotten data, which is collected, it might be sitting somewhere in your data warehouse, some of the columns which are not mapped to any of the reports. Go and find those data. There could be other data which is not digitized. It could be in various other remote parts of the business. And there could be data which is used only for a single purpose. You specifically needed it for a purpose, you collected it, and you're not using it beyond that. So find new uses for the data, and that is what the concept of dark data is about. After you've exhausted all of the available sources in the first 2 stages, stage 3 is when you need to tap into new data sources and find how you can get some more juice from your data by tapping into these other aspects. When you say business insights and AI should become business as usual, it has to be a cultural thing. When you set up data engineering and processing, like the big data technology, the earlier presentation was talking about data governance and some of those initiatives. So there, information technology is the key enabler. Data is a product, data is the output that you finally get and you're trying to use that. Whereas in data science, when you talk about coming up with decisions, coming up with insights from data, insight is a product, analysis is a key enabler. Whereas when you come to data-driven decision making, if you're looking at this getting done across the organization, culture has to be the key enabler. So the decision being made is the end product, but the culture has to be the enabler. How do you inculcate a data culture? You have to take multiple steps in terms of still having a strategic direction that yes, data is important for the organization. There are several organizations which have done that. We'll see some examples. And also looking at data literacy, how you can educate everyone in non-data related roles so that they understand what to do with the data, how they can take decisions using the systems. So there are several steps that you need to take and constantly keep messaging, use it, and run your reviews with data and tie all your decisions back to data to the data that you collect. When you do that, slowly data becomes second nature to teams within the organization. And there are organizations, the biggies, who have done that successfully. Amazon, Google, Microsoft. They not only have data products or data offerings, but they use data to run their business internally. There are several case studies of how Google collects data, and their HR, pretty much all the HR processes are based on data that they collect about their employees. And there are several examples like that. So data is very much something which runs the entire organization. When you get into that stage, that's when we call that as a data culture driven organization. So to summarize phase 3 in integration, we're talking about how you can propagate it organization-wide and excel at mature execution. So this is an ongoing process. So as this space is also rapidly changing, the kind of tools, technologies, skill sets are fast evolving. So it's best to keep an agile mindset, agile kind of a methodology for execution of projects. And the hub and spoke model, which we saw also, is something which is slightly flexible, where you can move things around and dynamically form teams and execute initiatives. A final case study, that of Netflix. So Netflix is a great example of an organization that has data culture. Many years back, even before AI or the machine learning algorithms were popular, some of you might have heard of the Netflix $1 million prize. How many of you have heard of? Okay. There was a Netflix prize for $1 million to build the best recommendation algorithm. Okay. So this was, I think, almost 10 years back. And they already had a recommendation algorithm internally. They had a machine learning algorithm which was working and recommending movies to users. But they wanted to do more, and they wanted to tap into the public knowledge. So they launched a $1 million prize, and the ask was that the new algorithm, anyone who can come up with an algorithm which beats their algorithm by certain percentage points, they were giving out $1 million prize. So there were several teams, it ran for almost a year, and there were several teams around the globe who worked on it. A lot of hyper optimization, machine learning, AI models were submitted, and finally they picked a winner. And the side story is that the prize-winning algorithm was not implemented. If you try and understand why, they actually implemented the algorithm which ranked second. So a classic case of machine learning engineering, because the one which won the prize by the percentage points was super optimized, and the effort needed to implement it was so costly that they picked the second one, which was a few percentage points lower, but was much more simpler and good enough. So this is a common thing you find in AI and machine learning. It's don't go blindly after accuracy. You have to look at how you solve the business problem. Is it better than what you're doing today? How you can optimize it over time, because you need to look at the costs associated with it. And there's a lot of buzz today, these days, around green AI. While last couple of years, people have been happily firing the machine learning algorithms and setting up on the cloud. AWS gives 1 year free account to anyone who signs up. And similarly, there are free cloud credits which most of the organizations have been giving. So it's kind of, they are inculcating a habit of irresponsibly setting up algorithms, because most of these algorithms, most of the neural networks, they are energy guzzlers. They run for hours or days, and they take up so much energy. Like one algorithm, there was a recent paper, I can share that offline. There was a recent paper which said that a few hours of an algorithm running is equivalent to an entire lifetime of car running on the American roads. So that is the extent of energy usage that AI algorithms have, and people are now talking about how we can be more efficient. Do you really need to do hyper optimization and things like that? So coming back to the point, Netflix was the organization which started this very early on, and it's used not just in recommendation, which is a very visible part. AI is used in a lot of other areas, even content creation. How many of you have heard about the House of Cards case study on how Netflix used big data to create the episodes? So do check it out. That's another classic case of how data has been used for public consumption. And similarly, distribution. Even the thumbnails that you see on Netflix, no two thumbnails may be the same. But depending on the user, depending on your preferences, whether you like a lead actor, or you like a genre, or you like a certain kind of color, they optimize the thumbnail, and you might be seeing your own unique thumbnail for a movie. So it's and they find out which thumbnails, when you optimize it, what kind of thumbnails do people click on. So for a single movie, there could be hundreds of thumbnails created, and it is optimized. So this is the extent of micro segmentation which is possible with data, and Netflix does all of that. And similarly, beyond the market-facing products, there are so many other cases where Netflix uses data internally. A classic case of a data-driven organization which has kind of reached this third stage. So that is a summary. Let's wrap up. So the three stages we looked at: experimentation, expansion, and integration. You start like a startup, start small, just get things done and show some quick wins. Second stage is expansion, where you move from pilots, move on to projects, and you show some maturity. And third stage is where you inculcate data culture and see how this can propagate across the organization. So, just a closing note, AI, we already spoke about the buzz around AI. And this is quite like the dot-com days where everyone was trying to have their own website. So there's a rush that if you have a dot-com presence, probably your business will take off. So AI is quite like that. Everyone adds the label driven by AI. And there was also another recent report which said that large percentage of organizations which claim to have AI don't have any AI in them. So for strategic differentiation, it's important to understand how you can adopt AI. So tying back to the title, the real differentiation comes in right adoption and right scaling across the organization, because then teams start acting on data as opposed to gut feel. Thank you.